Something was observed, something was measured, and then it was quietly sealed away. No public photos, no official press briefing, not even a basic release of raw data, just silence. The James Webb Space Telescope, humanity's most powerful eye in the sky, aimed its gaze at something moving through our solar system. It recorded, it scanned in infrared, it collected detailed spectrographic data, and then nothing. The results were embargoed. And when asked why, even some of the team members said they haven't been given access yet.
And probably a month or two to write a new paper about it. So we might, at the beginning of October, we might see the paper.
But the object? It's already here, already moving, already leaving. So the question remains, if there's nothing unusual, why hide the data, and why does this keep happening? Because this isn't the first time. The Webb telescope has looked at other strange objects, and each time, just like this, the information goes dark. Not by accident, by design. This silence, it's structured, embedded in policy. It's the way the system works. Because contrary to public belief, James Webb doesn't belong exclusively to NASA. It's managed by the Space Telescope Science Institute, a private research body. And who decides what the telescope looks at and when? Not the public, not elected officials, a peer-reviewed panel. Scientists, yes, but also gatekeepers. Every year, researchers compete for observation time. They submit detailed proposals, pages of scientific jargon, models, predictions. If accepted, they get exclusive access to whatever the telescope records. The raw data is locked. For months, up to a year. Only the original research team can see it. Only they can publish. Only they can choose whether to share anything at all. That's what happened here. An object designated 3I Atlas. The third confirmed interstellar visitor to our solar system. A team led by Dr. Martin Cordiner submitted a successful proposal. They observed it using Webb's infrared instruments. They recorded over 40 gigabytes of raw spectral data, an enormous cube of light and heat signatures. And they locked it. The minimum embargo period, 3 months. They could have waived it. They didn't. Why? Why would a team observing a rare interstellar object, something that will never return, choose secrecy? They'll say it's standard, that they need time to analyze, that academic credit is at stake. And yes, that's true. But this isn't a black hole in a distant galaxy. This is an object inside our solar system right now. It's moving fast. And when it's gone for good. So again, why hide it? Even stranger, another group, led by Matthew Pellico, used director's discretionary time to observe the same object. Their data? Public. Immediately. No embargo. 2 teams. Same object. Same telescope. Different rules. What did the first team see that the second one didn't? But it gets weirder. The orbit. Most interstellar objects crash through our solar system at steep, random angles, like cosmic debris tossed in by galactic tides. But 3I Atlas, it's retrograde, moving in the opposite direction of the planets, already rare. But its trajectory is also almost perfectly aligned with the ecliptic, the flat plane that Earth, Mars, and Jupiter all share. Only 5 degrees off. That's not random. That's precision. Most debris doesn't come in that flat. It dives in from above or below. But Atlas? It's flying like it belongs here. Then there's the path it takes. Mars, Venus, and Jupiter, in that exact order, like a sequence, like it's collecting data. Mars, the red dust. Venus, the inferno. Jupiter, the gas giant. A tour of our solar system's most extreme environments. Not inward, not being pulled by gravity, but flowing outward, almost deliberately. Not falling, flying. Harvard astrophysicist Avi Loeb noticed. He calculated the odds of such a path happening naturally, 1 in 20,000. And this isn't speculation. It's published, peer-reviewed, contested, yes, but not dismissed. So why the silence? We've seen 3 confirmed interstellar objects in just 8 years, after centuries of nothing. Oumuamua, Borisov, now Atlas. Each one strange, each one moving too fast, arriving too suddenly, leaving too quickly to investigate. Have they always been passing by and we just didn't notice? Or are we entering a region of space where objects or something else starts drifting closer? The patterns are starting to stack. The same region of entry, the same angles, the same mysterious properties. Oumuamua wasn't a comet. Borisov wasn't a typical interstellar rock. And now Atlas, following a path that defies natural explanation. And it's not just about the data, it's about timing. Because just as Atlas is set to pass closest to the Sun, its perihelion, the moment when it sheds dust and ice and reveals what it's made of, we'll lose it. In late October, from Earth's perspective, the object will pass directly behind the Sun. Ground telescopes won't see it. Hubble will be blinded. Even James Webb, sitting a million miles away, has blind spots to protect its instruments from solar glare. The timing couldn't be worse. Just when we could learn the most, it vanishes, not into deep space, but into a solar blackout. And when it re-emerges, it'll be dimming, fading, leaving the system forever. But there's one final hope. 2 spacecraft, already in motion, will pass close to 3I Atlas during its active phase, NASA's Psyche and ESA's JUICE. Neither mission was designed for this, but they'll be within 0.30.4 AU of the object, close enough to see it, maybe even scan it. But to do so, they'd have to burn fuel, shift course, risk their missions. In deep space, that's not a small decision. The mission teams will have to decide, stay the course or take the shot. And then there's Avi Loeb's wild idea. Use Juno, already orbiting Jupiter, to slingshot toward Atlas. A deep space intercept, a historic first. On paper, it works. In reality, Juno's main engine is failing. Fuel is low. Time is short. Most call it science fiction. But if it worked, it would change everything. Because once Atlas slips past Jupiter, it's over. The coma will fade. The signature will vanish. It'll be gone. Lost to deep space, no rewind, no second chance, and we'll be left staring at encrypted data files, wondering what we missed. James Webb saw something. The data exists. The spectra, the infrared scans, the emission lines, they're real, and they're locked. Maybe it's just ice and dust. Maybe it's nothing at all. But maybe, just maybe, it's something else. Not a discovery to hide, but one to prepare for. Because maybe it's not about protecting the data. Maybe it's about buying time. Time to interpret, to understand, to soften the message before the public sees it raw. Because if it isn't random, if it isn't natural, then it's not just science, it's existential. What if this object was sent? What if it's scanning, listening, or even watching? We once believed space was quiet, predictable, lifeless. That illusion is fading, and what's left is the unknown. So ask yourself, if this isn't a cover-up, then why does it feel like one? And if the sky really is silent, why are we constantly being told not to listen? If you're still watching, still wondering what's out there, subscribe to Curiosity Lab. Then stay with us, because the silence won't last forever. And the next visitor might not be passing through. It might be coming to stay.